what I want then for that assignment, which is, I think it's titled Intro Through Lit Cited on Canvas, and that'll be due Wednesday instead of Monday. I'll change that. What I want is this. Your intro is new, right? You haven't turned that into me yet. The discussion and Lit Cited are new. You haven't turned those into me yet. But the method section you have turned in. I have given it back. I want it revised. It's got to be revised, or I'll be very upset. Because I put a lot of effort into it. It takes a long time to grade 47 of those things. Same deal with the results section. You've got to revise it based on my comments. There are comments that are sort of are attached when I return this thing to you. But then there's also embedded comments in the paper itself. And I put a deal up on a video up on Canvas in the Pages section. It says how to see embedded comments. Do that. You have to do that. So I put a lot of effort into those comments. So please do that. The point is, I want you to learn how to write a scientific paper. That's why we're going through these gyrations here. So that when you're done with this class, you'll have a pretty good idea of how to put together a scientific paper, and you have done it a couple times. So yeah, that's what I want for Wednesday. If you have particular questions about your paper, please ask me. Ask me so I can help. I'm happy to go over yours with you individually if you want, or whatever. So please do that. The results sections, I ended up putting the same comment on lots and lots of papers, and because of that I want to go over the results section in a bit more detail today. Seems to be a little disconnect between what I was expecting and what you all were expecting for that. So the first question when you're writing a results question or a results section is what is it that we expected to find? What is it that we expected to find in this? And I think we all had some expectations of what might be different between the area where honeysuckle has been removed and the area where honeysuckle is still dominant. So what are some of the things that we expected to find? These would be like hypotheses, right? What expectations did you have? This is easy. Yell out something.
What species on the side that honeysuckle has been removed from?
A difference in species richness, maybe.
Yeah.
Right? That's the number of species. What else?
Dominance of honeysuckle on the honeysuckle side.
Yeah. So we expected to find more honeysuckle on the honeysuckle side. It canopy, right? Because that was the point, right? If you remove honeysuckle, you would expect to see some difference there in the amount of honeysuckle canopy, right? There's a difference between honeysuckle above you and honeysuckle at your feet. What we care about is honeysuckle above you, right? That's the stuff that was removed, that 40-year-old, 20-foot tall honeysuckle. There might have been some honeysuckle at your feet on the honeysuckle dominant side, yeah, on either side, right? But that wasn't exactly what this paper was dealing with, right? So we expected to find more honey canopy on the dominant side. What else? What else?
Difference in species coverage.
Species coverage. Okay. Percent coverage of the vegetation overall. Is that what you meant?
Sure.
Okay. Then what else?
No honeysuckle and river or
No honeysuckle at your feet? You mean the,
Yeah,
the low stuff on your? Yeah.
yeah.
So maybe we could just say percent coverage of non-native would be different. Percent coverage of natives might be different. Native species. Can you think of anything else that might be different? This is a pretty good list. What about, these are all sort of aggregate measures, right? You've combined things together to get these. What about maybe some specifics like you might think there might be some different species on either side. I don't know. Where honeysuckle is dominant, maybe certain things flourish. Where it gets removed, then those things don't flourish anymore. Could be. So these are things that you might think would happen, right? Okay. So which of these can we address with the data that you collected? Can you address whether there's a difference in species richness? All right. Can you address whether there's a difference in the canopy of honeysuckle on either side? Yeah, most of you collected some data on that, right? Vegetation overall percent coverage? Yeah? Okay. Percent coverage of non-natives? You know which ones are natives and non-natives, right? We talked about this in lab. Same deal with natives then. Different species, you wrote down the species, right? So you could look, see which things are listed on one side versus the other. Okay, so these are all expectations, and they're all things that you collected data on. Which of these things should be in your paper? Is there any you should leave out?
No.
No. These should be in your paper. These are things that you thought would be different, or could be different, and you collected data on it. Put them in. You got to analyze those data. You got to present those data. Okay? So all of these go in the results section. Okay, so then let's say you've got these data now. You've got data on species richness for each of your quadrats. We looked at it, my data set the other day in lab. It's in the video online. You've got species richness. You don't want to present your raw data, right? You don't want to just put down, we found 3 species in quadrat 1 on the honeysuckle side, we found 2 species in quadrat 2 on the honeysuckle side, and so on, because that's too much, right? That leaves it to your reader to figure out what it means to analyze it, right? You're supposed to analyze it. You're supposed to try and figure out what it is telling us. What are some ways of analyzing species richness data? Instead of giving all the data, what would you give us for the honeysuckle side? The mean, right? The average of what you found. Okay. But remember, the other day, in lab when we were talking about if you've got data that looks like this. Here are your two means for the honey side and the removed side. This tells you something, the means do, but there's a big difference between means that have standard deviations that look like this and means that have standard deviations that look like this. Remember that standard deviation is sort of the variation around the mean that's actually in your data. Right? If you have a huge amount of range of values here that you collected out in the field, boy, it's really hard to say what's going on out there. Right? I mean, this is your mean, but come on. There's a lot of, there's a lot of stuff going on out there. We don't really know where reality lies. Whereas if your mean is pretty tight, or excuse me, your standard deviation is pretty tight around your mean, you can say, well, we've got it pretty well narrowed down. We know what's going on here. We know what's going on here. We can say there's a pretty good difference between these two things. So because the amount of sort of variation in your data is important, that's another thing that you should report. Usually people report it as standard deviation. That's what I suggested. Another way is to report it as standard error, but standard deviation would be fine. So mean standard deviation is another thing that should be reported, because that lets people know what's going on here as far as, you didn't give them all your data. If you had given them all your data, then they could just look at it and say, oh yeah, there's a lot of variation there. But we don't do that. And we never just give out all the raw data, because it's a pain in the butt for the reader. We do the statistics for them. We do the statistics for the reader. We give people the means, we give them the standard deviations. What else are you going to do if you want to really know if it's a statistically significant difference? You've got to do the t-test, right? You've got to do a test, a statistical test, too. So this is another analysis. Some sort of statistical test. And along with that statistical test, there are certain things that you report. You always report the degrees of freedom. You always report the t-statistic. And you always report the p-value. And, we're not a stats class here. It doesn't, we could go into what these things exactly mean. But the one that's most important to us for the purposes of this class is just that p-value. Right? But you always report these things, so we've got to get them in there. And what this gives us then is a way of determining whether we can really say that the difference between those two means is real. Right? Because it goes back to this variation around your data. Right? If you had tons and tons of variation in the data that you collected, then it's going to be really hard to say that these two means are different. But if you're pretty tight in your variation around these two means, then you'd say, oh, okay, yeah, they don't overlap at all. Right? They're probably different. So that t-test is very helpful in trying to show the reader that, you've got this mean here, they look different, and they are. They really are. Okay? All right, so for the analysis of the difference in species richness, you might present these things. Would you present the same thing for the honeysuckle canopy? Yeah. You've got maybe percentages, right, for each of your quadrats or each of your transects. You can get means for those. You can get standard deviations based on those means, or that relate to those means. And you can compare the two statistically to say, yeah, there is a difference between how much honeysuckle canopy is in the place where it was dominant and how much honeysuckle canopy is in the place where it's removed. If they're the same, well, it kind of makes you wonder about your original question, right? What about percent coverage? For vegetation overall, can you give means? Standard deviations? Can you do the t-test? Nod your heads. Non-natives by themselves? Yeah. Natives by themselves? Yeah. All those things. And you should, right? You need to analyze these data. There's no reason why you would analyze just one piece of your data. You should do it all, right? Okay, so this one down here is a little different, right? You don't have numbers for what species you have. You just have names, right? And so for that, you might just be looking at, all right, so what did we find on the honey side that we didn't find on the removed side? This is one where you could put in a table, right? Maybe it would be a list of everything that you found on the honeysuckle side matched up with what you found on the removed side, and then the differences down at the bottom of the table. I don't know. Some way of showing that, if there is a difference between these two, what the difference is, or if there's not a difference between the two, that's kind of interesting too. You might think that with this huge change in vegetation that's out there between one side and the other, that certain things would thrive in one and not in the other, right? Yeah.
So formatting, if we use it like that, like all of our tables, you want it below the text that we put in, or do you want it after the paragraph that we talked about?
Yeah, so after the paragraph is fine.
Okay.
Yeah. If we were doing this to be submitted to a journal, they always have you put it on a totally separate sheet of paper at the very end, but for this, it just makes it easier to read. Just stick it in. If you do a table or a figure of any kind, you've got to put a caption in down here. Table 1, and then that caption has to describe in detail what you found, what's in that table. It's got to be sort of a lot of people when they're reading journal articles, they just look at the pictures. It's like going back to grade school before you learn how to read words. You just look at the pictures and make up the story. That's the way a lot of scientists read articles, is they just flip through and look at the pictures. Flip through and look at the figures and the graph and the tables, and that often tells the story, right? And so that's why you need a detailed caption here, is because this might be the only thing that somebody looks at in your paper. And so they need to know where you were, what you were doing, and what's in this table here. What does it show us? Okay? Okay, so we've done this analysis here. We've got mean, standard deviation, t-tests for all of these checkmark things. We've maybe got a table in here of different species, or it could just be in paragraph form in a list. Now we've got to write it. You do the analysis, then you have to write it up. Well, you want to write things concisely and in a form where you're not repeating yourself a lot. So the first thing is that you don't repeat anything in the methods, right? Because they just read the methods section, right? So you don't need that in your results section. You start in with what are the main results, or you start with what you think your main result is, or just with the result that's easiest. To me, it seems like the easiest thing to talk about would be what species we found. And you could start with, we found that let's see, where honeysuckle how about we say we found 4 species where honeysuckle is dominant, and 12 total species where it's been removed. And then if you had a table at the end of the sentence before your period, you might put in Table 1. Table 1, that points the reader to the table, which then gives them the list of what all those species were and shows them what are different. If it shows them what's different between the two, you should probably point it out here as well.
Would you want us to break that up into native and non-native in that sentence too?
Sure.
Yeah.
You could. If you think, this is your paper, right? You think about what is important here. Hopefully you've done the lit search now. You have some idea what people have found happens when honeysuckle invades. You might have some idea what people think are important about why would you remove honeysuckle. I'm not going to spend $100,000 removing honeysuckle out here if all I get out of it is more non-native species. What we really care about is what happens to the native species. That's the point of removing honeysuckle, is to encourage the growth of native species. And so making that distinction between native and non-native is going to be important. It may be, however, that you don't have enough data. For example, over here, if you break up species richness into native and non-native species richness, you might, your t-test might show that there's no difference between where honeysuckle is dominant, where honeysuckle is not. Just because you've got your numbers are so small, right? You only did, 5 quadrats or something. So your numbers are small, it makes it hard for this t-test to show you a difference, unless it's huge difference, right? So in some cases, you could do that, you could break it up, but then you should probably also analyze it with it put together too, because it wouldn't be telling the whole story if you wrote that, well, we found no difference in species richness between where honeysuckle is dominant, where honeysuckle is removed for native species, and we found no difference in species richness for non-native species, when really there is a difference, but you have to combine native and non-native together in order to actually see that difference, just because our numbers are so small. So my answer is sort of yes and no. Yeah, you want to split them apart, but if you split them apart and find that, well, we lose our significance here when you split them apart, then you should also combine them together to show, if there is a significance difference there, to show that, yeah, there is something that's happening here. It's not that nothing happened. It's not that there's no difference. It's just that our numbers were just too small to show that difference. Yeah, so you know your next sentence could be about number of natives versus non. A sentence after that could be specific species found in one but not in the other. When I say one or another, I mean the honeysuckle side versus the removed side, not one quadrat to the next. So this might be one way to start. Then that sort of leads you to this, your actual numbers here for species richness. These are the totals here. Your numbers over here are averages, right? Means. So with that in mind, let's just say that you did the t-test, right, for difference in species richness. And in that t-test, it gives you the means that's one of the values you get out of that t-test. Another value you get out of it is DF, it's degrees of freedom. It's one that you always report, so it's an important one. Degrees of freedom is going to be 4. It's going to be 4 for the test. Your T stat, I don't know, negative 7.2. And then your two-tailed P, .03. Oh wait, we need standard deviation too, right? Well, you got to get that a different way. Look at the video online. I've got it online there, so you can look at it again. Standard deviation, you actually use that, what is it, descriptive statistics. And that'll give you standard deviation for honey and for removed for species richness. Might be 3.1 and 2.7 or something. Standard deviation. All right. Well, you've got all these numbers here, and you could write, 1, 2, 3, 4, 5 sentences. You could write 6, 7 sentences and fit all those numbers in, or you could put them all in one sentence. And what the editor of your journal wants you to do is fit them all into one sentence. Because it's concise, and if you're used to reading these things, then it's clear to you as well. So, the sentence you could write is maybe we found significantly more species where honeysuckle was removed. Put in parentheses then the number of species, the mean here, plus or minus standard deviation we found significantly more species where honeysuckle was removed than where was still dominant, or where honeysuckle was still dominant. You can put the mean for where it was still dominant here. X bar equals 6 plus or minus 3.1. That's the standard deviation. Then you've just used this magic word right here, significantly more. That means you've done some statistics. If you use the magic word, you have to back it up with statistics. If you're reading a scientific paper and you read the word significantly, that means they did statistics. So you got to put your statistics in too. That's where you put the semicolon in, and you put T, because you did a t-test. You put in the degrees of freedom equals the t-stat, negative 7.2. Okay, so that's one thing that this means something to some people, right? To me, I usually gloss over it because it doesn't mean anything to me. But the p-value means something to me. I know what that means. Capital P in italics equals 0.03. Period. So within this sentence, it says you found more more species where honeysuckle was removed. It gives you the means plus or minus the standard deviation, how much variation there was in your data around those means. Then where honeysuckle is still dominant, here's the dominant mean plus or minus standard deviation. And it gives your statistics to back it up. Right? What if our p-value was 0.08? What would my statement be? Same thing?
No, it was essentially the same.
Okay, yeah. Or we found no difference in the number of species where honeysuckle was removed. Still, it's mean plus or minus standard deviation, whatever. And then where honeysuckle was, let's see, we found no difference in the number of species where honeysuckle was removed. I don't know if you'd say then, I guess it would be and or something. Anyway, your p-value here is 0.08, and that lets you know. The magic p-value that most people use is 0.05. If it's greater, if p is greater than 0.05, that equals significant. If it's less than 0.05, you'd say, well, sorry, I've got it backwards. No, you guys got to help me when I do it wrong here. Less than 0.05, it's significant. It's greater than 0.05, like 0.83, then no, we can't say that there's a difference. What if it's right on the line? It's 0.051. Well, you can say it was moderately significant, or it trended towards significance, or it looks to be potentially significant, or yeah, something like that. When your numbers are as small as yours are, just having 5 on each side, it's hard to get a p-value that's really low. It has to be a huge difference in order for there to be a p-value that low. Okay, so we found no significant difference in the number of species, whatever. All right, so we've talked about species richness. We talked about, we haven't talked about this yet. This might be, you need to do it, right? You did the analysis here for percent coverage vegetation overall. You did it for non-natives by themselves. You did it for natives by itself. you got to put that data in as well. You know, you might start with something saying that we found that there was, you know, very little vegetation coverage on the side where honeysuckle was dominant, and much more so on the side where honeysuckle was removed. For example, percent coverage where honeysuckle was dominant was whatever your mean is, plus or minus standard deviation. You always put that in, which was significantly more than where honeysuckle has been removed. Mean plus or minus standard deviation. You use the magic word significantly, so you got to put in the statistics at the end. Say the same thing about native versus non-native. Maybe there was no difference in the amount of non-natives on one side from the other. That's fine, right? You're just trying to figure out what it is and let people know what you found. But you got to put it all in, right? You got to say it all. Lastly, you've got this honeysuckle canopy on the dominant side. This sort of is the impetus for your paper, right? This sort of is, you know, if you don't find a difference between the two, then you're basically found that when you remove honeysuckle, it's still there. You did a terrible job of removing it, right? Or you chose a really bad area in order to do this comparison because there wasn't any honeysuckle on the side where you say honeysuckle is dominant, right? So, you know, this is just proving to people that where you did this study really was what you're trying to describe it as. And so maybe it's a good idea to, maybe this is something that you would put first, maybe even before this. Right? We found that honeysuckle canopy was averaged 87%, plus or minus standard deviation, which was significantly more than 0%. Nobody should have gotten more than 0%, I don't think, on the honeysuckle removed side. There was no honeysuckle canopy on that side. There was no honeysuckle over your head on that side. So, unless you found a really weird spot, that was what I saw anyway. And so if you say that there was significantly more, then yeah, you've got to back it up with your statistics, right? So when you're doing this analysis here, you try and think about what are all the potential things that might be different here. And you think about, why do what things do I expect to be different? And those would be things that others are going to expect as well when they're reading your paper, and they're going to expect you to address those things. Right? So you got to address those. What questions do you have so far? Yeah.
When was honeysuckle put into
Nobody knows, but the honeysuckle that was removed, and actually this was in 2001 or 2002. A lot of them were around 40 years old at that point. So they're in their 40s or 50s. Yeah.
So, would you rather us, I was trying to be like short and concise with the articles, but I feel like there's so much to include, so would you rather us be too long? Because like, before I felt like it was like, we were like only,
Yeah.
4 sentences, and it was hard, because I thought it was hard to include all of this in a small space, so I feel like that's why I wanted us to that, because we know what was important.
And in your example paper too, like yours was really like short and concise.
Uh-huh.
So is it that, because I would need like 4 paragraphs and be like, talk about all this stuff.
Okay.
So is that,
Well, you've got to address the data that you have.
right.
So, I tend to be very cryptic in my speaking and writing. and so I don't say very much, right? And so for me, this might be, this is 3 sentences here for me, and this is, what I've got here, 2 sentences, or 3, and another sentence there. So, you might put in a little bit more, but I don't want you just repeating stuff.
Yeah.
I don't want you to say that we found more here than there, and then say we found more here than there, and then put your numbers in. If you say it, you've said it, right? So, and it might just be that I don't think about all the stuff that I could say, and you can, and that's fine. So, I'm not going to grade you down if you write too much, probably.
Okay.
I might cross it out if I don't think it's worthwhile. But yeah, and that's it's the same deal with editors too. They're constantly crossing stuff out of your paper that you thought was really important. Thanks for that.